Hello everyone, welcome back to the 8th video of this series where we are solving past 25 years of JEE Advanced question of kinematics. So this question was asked in JEE Advanced 2022 and this is given that at time t equal to 0 a disk of radius 1 meter starts to roll without slipping on a horizontal plane, okay, with an angular acceleration of 2 by 3 radian per second square. A small stone is stuck to the disk. At t equal to 0, it is at the contact point of the disk and the plane. Later, at time t equal to root pi second, the stone detaches itself and flies off tangentially from the disk. Okay, the maximum height in the meter reached by the stone measured from the plane is this. Find the value of x. Okay, so I think suppose this is our disk and this is our plane. Sorry, let me draw in a better way. Suppose this is our disk and this is our horizontal plane. At t equal to 0, here is our stone from yellow color. Okay, I am denoting the stone. At t equal to 0, it is at the contact point of the disk and the plane. So this is the contact point and the velocity of the contact point will be 0 always. Why? Because it is saying that disk is rolling without slipping. Okay, if it is not slipping, what does it means? It means that there is no relative motion between the point of contact. So if horizontal plane is at rest, so this point of contact, velocity of this point of contact should also be 0. Okay, if it is moving with some if horizontal plane is moving with some velocity v, then the velocity of bottommost point should be v, and in this case it is at rest, so bottommost velocity of bottommost point should be 0. Later, at time t equal to root pi, the stone detaches itself. So after suppose after time t, this disk goes here. Okay, so this disk will do two motion. One is linear motion and one will be the rolling motion. Okay, so there will be two kind of motion. After time t, this disk will reach here and our stone will reach somewhere here. Okay, we can assume anything. This could be here or here. It doesn't matter. So at this time, the stone will detach itself and flies off tangentially. Okay, at this point, a stone will detach itself and flies off tangentially. Now this stone will do some kind of projectile. It could be like this or it could be like this. That doesn't matter. We can figure it out later. So there are two possibilities. Either stone will do this kind of projectile or this kind of projectile. We have to figure out the maximum height. This maximum height is given as 1 by 2 plus x by 10 and we have to figure out the value of x. So this is the question. Okay, all of you guys can pause the video. I have explained the question and try to attempt it. Once your attempt will be done, we can resume for the solution. Okay, so I am assuming that all of you guys have tried to solve it. Now I am starting the solution. Okay, so I am assuming like this stone will fall off like this. Okay, let's see what will happen. So first we have to figure out at time t equal to root pi what will be the position. What will be the position of this stone? How much angle it should have been traveled? Okay, so this is the uniform acceleration, uniform angular acceleration. So what we can say for uniform angular acceleration, the angle traveled by the stone will be theta equal to theta naught 1 by 2 half alpha t square. Well, alpha is the angular acceleration. The angle traveled by the stone is independent of the linear motion. I don't care what is the velocity, what is the linear acceleration, it doesn't matter. We have to calculate the angle, so it all depends on the angular parameters, that is angular acceleration. Okay, so theta equal to theta naught plus half alpha t square. Theta naught was 0. I can assume like this angle is 0, so theta will be half into alpha, which is 2 by 3 into t square, where t is equal to root pi. So t square will be pi and theta will be pi by 3. So okay, coincidentally we have drawn the stone at right position. So theta will be pi by 3. Okay, theta will be pi by 3. So initially it was here, now stone have been reached here, and the angle between this is pi by 3. Okay, this is pi by 3. At this point stone will fly off. Okay, so at this point what will be the velocity of the stone? So as we know, in pure rolling or suppose in any rigid body dynamics, if a body is doing linear movement as well as angular movement, so for any point, suppose center of mass is traveling with velocity v center of mass, okay, and the body itself is doing an angular rotation with an angular speed of omega. So every point will have velocity of vector addition between velocity of center of mass and the tangential velocity. So suppose this point, I can mark it with different color. This point will have velocity is equal to v center of mass plus omega r if it is doing clockwise angular movement. For this point, velocity will be v center of mass minus omega r, because omega r will be in this direction, tangential direction, and center of mass velocity is in right direction. For this point, tangential velocity will be in this direction and velocity of center of mass will be in this direction. So the net velocity of this point will be omega r in y axis and velocity of center of mass in x axis. So in this way, I hope everyone who is watching this video, they know the vector addition and the basic concepts of the rotation. Okay, for this point velocity will be v center of mass here and omega r here. Okay, so let's come back to our question. At this point where stone, I can draw the diagram again, where stone is somewhere here. Okay, so omega r will be in this direction plus velocity of center of mass will be in this direction. Okay, so net velocity will be this of the stone, and with this velocity stone will fly off. Since we are interested in the maximum height, now maximum height traveled by the stone is dependent on the vertical velocity. It does not depend on the horizontal velocity. So velocity of center of mass will have no role over here. Okay, velocity omega r will have role to calculate the vertical distance, and that too, suppose this angle is theta, omega r sine theta, which will be the vertical component. This omega r will have two components, one is omega r sine theta and one is omega r cos theta. So omega r sine theta will have role in the calculation of a vertical height. Okay, so what will be the height? We have already calculated. This is pi by 3. So this will be 90 minus pi by 3, and this will be again pi by 3. So this theta is nothing but pi by 3 only. So velocity will be vertical, v vertical will be omega r sine pi by 3. Okay, now let's calculate what was omega r. Omega, how can we calculate? Okay, so we have angular acceleration, omega is equals to omega naught plus alpha t. Omega naught was 0 because it tells that it starts to roll, so we can safely assume that initial angular velocity was 0. So omega will be alpha, which is 2 by 3 into t, which is root pi. What is radius? Radius is 1 meter, so velocity is equal to same as angular velocity. Value of r is 1, root 3 into 2 pi into 1 into sine pi by 3, which is root 3 by 2. So overall, if you calculate, this will be 2 se 2 gaya, it will be, velocity will be, let me do, sorry, velocity will be root pi by 3. This is root pi by 3. Okay, I've put back the value from here. Value is equal to root pi by 3, and if we calculate height from this, v square minus, now this is the question of complete projectile. Okay, this is simple. What we can say is that this is a stone, we have thrown it up with the velocity of root pi by 3. So how far it will go? So I can use third equation, v square minus u square equal to 2as. Final velocity will be 0. At the maximum height, velocity will be 0. So this will be minus pi by 3 is equals to 2 into 10 into displacement. So displacement is nothing but pi by 60. Pi by 60 is my vertical height, and the one thing is, the point to be noted is, this was the initial position of the ball. It was already some distance above from the ground level. Okay, we have to calculate the height from the ground level. So it was already this distance. I am redrawing the diagram. So stone was here. From here we have calculated the maximum height. This is the maximum height. This point was already some distance above from the ground level. Okay, which was, suppose this angle was pi by 3. So this distance will be nothing but r minus r cos pi by 3, which is cos 60 is 1 by 2. So r by 2. Okay, so this distance was 1 by 2, and again then this distance will be again 1 by 2. So total distance from the ground will be, this distance we have already calculated, which is pi by 60. This is 1 by 2. So total distance will be 1 by 2 plus pi by 60. And if I know, okay, they have written in the same form, 1 by 2 plus x by 10. So if I rewrite it as x by 10, it will be 1 by 2 plus pi by 10 into 6. So answer is x is nothing but pi by 6. Okay, so what will be x? X is 3 pi is, we can write it as, should I write it as 22 by 42? Okay, so this is approximately 0.5. This is 0.5 is be 21. Okay, so something like 0.51 or 0.52. Okay, so here is the answer. We can for single digit we can write it as 0.5. Okay, so yeah, I hope you guys understood the way we have solved this. There was two kind of things which we had to take care of. One was the projectile motion, and one was we have to figure out the net velocity. Okay, and since this question was from the rotation side, but really we don't have to take care of anything. We as you have seen in the solution, I never tried to went for the linear acceleration or linear velocity. It was completely independent of these two factors. We just have to take care like where the stone was and what will be its velocity. Okay, and this velocity was nothing but the vector addition of two things. One is linear velocity of center of mass plus tangential velocity of the point. Okay, where this point was doing circular motion along the center of the disk. So I hope you guys understood the question, and yeah, let's meet at the next video. Thank you guys.